All right, ninth graders, the last thing that we did was page 86 in your binder, and it was called rate of change, where we looked for like rate of change and we looked for change factors. And something that we keep seeing is these curved graphs, these exponential graphs. So today we are on page 87 and we are going to learn how to graph exponential graphs. So have your graphing self ready. I don't know. That was weird. Oh, hold on. Okay, can you see my screen right now? I think that's the wrong screen. Let's see if we can make this happen. I'll just stare lovingly into your eyes. Okay, we got it. Perfect. Okay, so we are graphing exponential functions. We've got 1, 2, 3, 4, 5, 6 problems here. And your job by the end of this is going to have some lovely graphs all over your paper. So we're going to start given this equation, y equals 3 to the power of x. So the way that we can find the graph of something if we don't know exactly what it's supposed to look like is by using a table. So 3 to the power of x, well, I have all these x values. Those are going to go in for x on my equation. So instead of y equals 3 to the x, I would have y equals 3 to the power of negative 3 because I'm putting the negative 3 in that y spot. So what is 3 to the power of negative 3? Well, I'll get to that in just a moment. This one would be y equals 3 to the power, I wrote 2, 3 to the power of negative 2, y equals 3 to the power of negative 1, y equals 3 to the power of 0, y equals 3 to the power of 1, y equals 3 to the power of 2. Again, I'm taking my x values, putting them in the exponent, and y equals 3 to the power of 3. So what are these going to look like? Well, you can type these into Desmos and you can change them back to fractions, which is way simpler than the way that I'm going to do it on my calculator, but I don't want to flip the screen back and forth a ton. So I'm going to start with 3 to the power of negative 3. And then I get this decimal. Remember on Desmos, you can push that back and forth fraction button. But if I push math, enter, enter, I get 1 over 27. So 1/27. I drew a backslash for my fraction, and I actually hate those. So that was weird. The next one, 3 to the power of negative 2 is 1/9. Did it again. Okay, 3 to the power of negative 1 is 1/3. And then 3 to the power of 0 is 1. 3 squared is 9. Hopefully you knew that in your head, maybe not. 3 cubed, oh my gosh, I skipped 3 to the 1. 3 to the 1 is not 9, Mrs. Johnson. Okay. 3 squared is 9. 3 cubed is 27. And 3 to the 1, which I hope you already knew, is 3. Okay, so 3 to the 1 is 3. 3 cubed is 27. Do you see like a pattern here? Because I definitely see this pattern. 1 over 27 is 3 to the negative third, and then 3 to the third is just 27. Remember how we talked about negative exponents being 1 over? That's what's happening here. So 3 squared is 9. 3 to the negative 2 is 1/9. 3 to the first is 3. 3 to the negative 1 is 1 over 3. 1/3. There we go. Okay, so what would this look like when I actually graph it? Okay, let's come over here to our graph, and we are going to start by putting our first dot at negative 3 up 1/27. So I go to the left 3 spaces, and I go up 1/27th of a space. That is just like barely above 0. 1/27th, if you were to take a pizza and slice it into 27 pieces, one slice when there are 27 pieces is really small. That means 1/27th is a very small distance. Okay, so the next dot is negative 2 up 1/9. To the left 2 up 1/9, still really small. And then we have negative 1 up 1/3, third of the way up. Then I go to the right 0 up 1. Then I go to the right 1 up 3. I go to the right 2 up 9. 6, 7, 8, 9. And then I go to the right 3 up 27. I don't think that's going to fit on my graph. Okay, so let's connect these dots. And it looks something like this. Mine shouldn't go over like that, but do you notice how I put arrows on the ends? Put arrows on the ends of your graph. That means it goes on forever. But what you'll notice is this would just keep getting to be a bigger and bigger denominator on our fraction, but it's never actually going to go into the negatives. So this line is never going to cross below the x-axis. If your line does cross below, erase and fix. Erase and fix if your line crosses below, because that is not allowed. It's just a smaller and smaller fraction. It's like getting closer and closer and closer, but it never actually reaches it. Okay, now there is a lot of stuff right here. I don't want you to focus on that just yet. We are going to finish graphing all the rest of these. So I'm going to do one more with you before I go over those things on the bottom. So let's look at problem number 2. Y equals 4 to the power of x. Well, I know that that would be y equals 4 to the power of negative 3. And then we have y equals 4 to the power of negative 2, because remember, I'm putting my x values there. Y equals 4 to the power of negative 1, y equals 4 to the power of 0, y equals 4 to the power of 1, y equals 4 to the power of 2, and y equals 4 to the power of 3. Get your calculator out and calculate those. Push pause because we're going to check in when I'm done calculating mine as well. Okay, I calculated them. Hopefully you did too. If not, you're probably just going to copy mine, making me do all the work. Shame on you. Okay, let's get these graphed though. The first dot is negative 3 up 1/64. That's a very small distance up. So negative 3 up 1/64. But remember, it's not at 0 and it's not below 0, so never make it cross down there. Then the next one is negative 2 up 1/16. Then negative 1 up 1/4. 0 up 1. 1 goes up 1, 2, 3, 4. 2 goes up to 16. Ooh, that was the very last dot on the graph. And the last one's totally not going to fit. Notice my graph does not cross below the x-axis. Oh boy, that was connected so poorly. Let's pretend like it wasn't as bad as I just made it. Okay, do you see how the next one gets a little bit weird? The next one, there's a 5 times 2 to the power of x. Ah! Okay, so what's happening on that one? Well, we can fill it in just like we filled in all the other ones. This is y equals 5 times 2 to the power of negative 3. Then we have y equals 5 times 2 to the power of negative 2. Y equals 5 times 2 to the power of negative 1, 5 times 2 to the power of 0, 5 times 2 to the power of 1, 5 times 2 to the power of 2, and 5 times 2 to the power of 3. All right, get those calculated. What are those? By the way, keep in mind here, you cannot do 5 times 2 first and then raise it to the negative 3. That is not following our order of operations. PEMDAS, people. You have to do the exponent, then you can multiply by the 5. So your calculator is smart enough to do PEMDAS. Your calculator, if you type in 5 times 2 to the power of negative 3, your calculator takes that into account and it gives you 5/8 for your fraction, or 0.625. I'm going to put down the decimal because sometimes 5/8 is a difficult concept to think about. I guess I don't have to, but we're going to. Okay, so 0.625. The reason I'm putting the decimal is because I have to actually graph that thing, and decimals are easier to think about when you are graphing. 5 times 2 to the power of negative 2 gives us 1.25. Again, that is easier to graph than 5/4 because brains don't always think in terms of improper fractions. Excuse me. Cough. 5 times 2 to the power of negative 1. And I get 2.5. Okay, 5 times 2 to the 0. And I get 5. 5 times 2 to the 1. And I get 10. 5 times 2 to the 2. And I get 20. Ooh, starting to see a pattern. Okay, and 5 times 2 to the 3rd, 40. I know I'm not going to be able to graph all those because my graph only goes up to 16 according to the last one. Okay, so -3 up 0.625. That is not barely above. That's actually over halfway. Nice. Finally, a little bit of a higher graph. The next one is at -2 up 1.25. So -2 up 1 1/4, right about there. And then -1 up 2.5, right about there. 0 is up 1, 2, 3, 4, 5. 1 is up to 10. And then I can't fit the 20 on there. You are going to be tempted to make this cross. It is not going to cross. Stop making them cross. It should just get closer and closer to the x-axis, but it's never going to cross the x-axis. We'll talk about that more on days to come. Actually, it might be today. I can't remember. Okay, on the next one, I want you to do the same thing. Make sure when you put your 1/2 in that you put that part in parentheses. I want you to finish up your tables for the rest of this page and get the graphs. Push pause. Please actually do it because when we go through this, I'm not going to explain that part. We're just going to make sure that you've got them graphed. Okay, so go. Okay, so I graphed all those. I'll kind of show you what your graph should look like. On number 4, you should have your table. It should start at, your graph should be turning the other way. I forgot my arrows on both of them. Okay, on number 5, if you want to pause it quick, you can check to see if your graph looks the same as mine. And on number 6, same thing, make sure your graph looks the same as mine. It's okay if you have fractions and where I have decimals or whatever. We'll get that all together. Okay, so let's talk about what the y-intercepts are and what the change factors are. So if we look at number 1, the y-intercept is where this thing crosses the y-axis. So what is my y-intercept on this first problem? Well, that y-intercept is right here. That is at +1. So I go to the right 0, up +1. Another way we sometimes write that is often you'll just write the number 1. But for this one, I'm going to write an ordered pair. I don't know why, because I thought to. Okay, so you can see that y-intercept right here where it crosses the y-axis. Okay, so then what's happening here? How do I get to the next dot? Well, this dot is up 1 space. Do you see how the next dot is up 3 spaces? So this was 0, 1, and then we had 1, 3, and then we had 2, 9. What's that pattern there? We keep going to the right 1 space, but then the y value goes from 1 to 3 to 9. What's happening there? Well, I'm multiplying that y value by 3. So timesing by 3. I want everybody with a pencil or a pen, a red pen would be great, multiply by 3 and circle it over there. That is what we changed by. That is called our change factor, and that goes right here, multiplying by 3. Our change factor is 3. So how do we go in the other direction? How do we go from 1 to 1/3 to 1/9? It keeps dividing by 3, but the way we say dividing by a number is just by multiplying the reciprocal. We're multiplying by 1/3 to go to the left, we're multiplying by 3 to go to the right. The reason I circled the 3 one though is because that is the actual change factor, because that's what takes us forward, which is why I wrote it here. Okay, a lot of stuff that we talked about there, but let's look at the next problem because we're going to find those same things. The y-intercept here is also 0, 1, up 1 space. The change factor, see how I go from 1 up to 4 to 16? Over here, it's multiplying by 4. That's my change factor because it moves to the right that way. So you are going to write 4 for your change factor. But then how does it move to the left? Well, to go that direction, it multiplies by the inverse, 1/4. And we could have started here, gone 1 times 1/4 times 1/4 times 1/4. Okay, let's go to problem number 3. What's the y-intercept? Oh boy, this y-intercept's higher. It is 1, 2, 3, 4, 5 up. So we would say 0, 5, or you could just write the number 5, totally fine. But what's the change factor? Well, we go from 5, then up to 10, and then it goes to 20 to 40. So what are we multiplying by? Well, to go from 5 to 10, I'm multiplying by 2. So how do I go from 5 to 2.5 to 1.25? Well, everything's getting cut in half. So over here, I'm multiplying by 1/2 to go toward the left. Notice the dot doesn't automatically drop down to the very bottom here. It just drops in half. Okay, let's look at number, and yes, I want to see these drawn on here. Also, I forgot to write my change factor. That is being multiplied to the right. It is 2. Okay, on number 4, my y-intercept is up here at +1. So I would say 0, 1, or you could just say 1. In our change factor, well, this is kind of hard to see. This one I can't, it's kind of hard if I was just looking at the graph to see what the change factor is. So I'm going to look at what it's multiplying the other way. So over here, it's 1, and then it goes to 2, then it goes to 4, then to 8. So on the left side, to go from 1 to 2 to 4 to 8, it's multiplying by 2. Don't you dare circle that. That is not to go to the right. That is the left direction, which is not our change factor. We need to figure out what it multiplied to go the other direction for our change factor. So how do we go from 1 to 1/2 to 1/4 to 1/8? Well, same thing we did on these. We flip it. So over here, it's multiplying by 1/2 as our change factor. Dun, dun, dun. Weird, different. Oh my goodness, it's a fraction. Ack. Okay, that's fine. We're done freaking out. 1/2 is the change factor there. Let's look at the next one, problem number 5. On number 5, we have a different y-intercept again. It is at +3, so I would say 0, 3, or I could just say 3. I know I keep saying that because I want it to stick in your brain. This one is doing something weird to the right again, so I'm going to check the left side, and then I'll just flip it to get the right side. So on the left side, I go from 3 up to 6 up to 12. So over here, I'm multiplying by 2. Don't you dare circle it. That is not your change factor. That is the left movement. How do you flip that to go to the right? Well, flip over 2, and that is multiplying by 1/2. Now you can circle it. Now that's your change factor. All right, and the last one starts at, where does that start? 1.5. So we would say 0, 1.5. We can see it in our table as well. And then how do we go from 1.5 to 3? And then from 3 to 6? And then from 6 to 12? Well, it's multiplying by 2. There's my change factor because it moves to the right. That means to the left, it multiplied by 1/2. If you're feeling confused, take a deep breath and realize that this is brand new. So I promise we're going to practice this a lot. And yes, I'm talking it all at you right now because it's new and we're still figuring it out. So don't feel bad if you still need a couple more days of practice before you totally understand this stuff. Okay, so we're looking at this and we've got a ton of stuff going on here. I'm going to zoom out a little bit. What do you see? Where did the 3 come from and where did this y-intercept of 1 come from if I'm looking at that equation? Where did the 1 and the 4 come from in that equation? Where did the 5 and 2 come from in that equation? Where did the 1.5 come from in that equation? Where did the 3 and the 1/2 come from in that equation? And where did the 1.5 and the 2 come from in that equation? Look at it, think about it, push pause for a second because we are going to talk about it. Okay, so what did we find here? Well, if you look at number 1, actually, let's start with one where you can actually see it really well. The 3 and the 1/2. 3 was your y-intercept, 1/2 was your change factor. Do you see how the 3 is right in front and the 1/2 is under the x? That means that your y-intercept was in the front and your change factor is underneath the x. Let's look at this one. 2 was our change factor, it's underneath the x. 1.5 is the same thing as 3/2 and it's in front. On this one, 1/2 is under the x, and the 1, well, technically we can always put a 1 in front of the whole thing. So 1 was a starting point there. On this one, 5 is in the front, 2, our change factor, is in front of the x, underneath the x, I should say. And then 1 is in front, 3 is underneath the x, 1 is in front, 4 is underneath the x. So what does that mean? Turn your paper sideways. We are going to write a note to ourselves. When we are doing these problems, it is always going to be set up this way. Y equals, and then after the y equals, you are going to have the y-intercept. I wrote that really weird. You could have just wrote like y-int. Then you're going to multiply by the change factor to the power of x. So you're going to find the y-intercept and the change factor from the equation, and it's raised to the power of x. This is going to be super important. So I'm going to write 2 stars. I feel like 2 stars with a smiley face even makes it more important. It's like super star eyes, happy. You are going to start at the y-intercept and use the change factor. So we are going to start at y-intercept, then use change factor. And I'll show you exactly what I mean because we are going to do the second page of paper so much faster than the first page of paper. So much faster. Ready? I mean it when I say so much faster. And by the way, we're going to get to this range and domains thing in just a second, so don't lose this paper. Okay, so we are going to start at the y-intercept, and then we're going to use the change factor. So using this thing right here, I'm going to rewrite that. I'm going to write y equals y-intercept times change factor to the power of x. And then I'm going to put my little star here again. Start at y-intercept, use change factor. Okay, I promised you quick graphing, and I will deliver quick graphing. So what is our y-intercept? What is our change factor? Well, on problem number 7, our y-intercept is the thing in front. That means our y-intercept is 2. And our change factor is underneath the x. So our change factor is 3. What does that mean? Well, I put my first dot at positive 2. Then my change factor is telling me multiply by 3 to the right. Well, 9th graders, what's 2 times 3? 6. Okay, so I move over a space and I go up to 6. What is 6 times 3? 18. Okay, I move over a space and I go up to 18. I'm done with half of my graph. Now I'm going to use my calculator for the left half because what do I multiply going this direction? If I multiply by 3 to the right, that's really 3 over 1. So flip that, it's going to be multiplying 1/3 to the left. So if I was at a dot on 2, turn on my calculator, 2 times 1/3 gives me my next dot at 0.66666 blah, 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 7. Okay, so I go to the left a space and up to 0.666 blah, 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 7. Times that by 1/3. And I've got 0.22222 times 1/3. And I've got even smaller number. These numbers are going to get smaller and smaller and smaller. So once you get to those really low decimals, just know that every dot is going to get so much closer to 0, but it's never actually going to cross 0. So let's connect our dots. And that was way faster than drawing a table. If you're really bad at connecting these dots, try to get better because it's a fun little challenge. Okay, let's go to problem number 8. Again, no table on problem number 8. The y-intercept is in front. The change factor is beneath the x. So my change factor beneath the x is 2. My y-intercept is 4. So I would start with my first dot at positive 4 on the y-intercept. And my change factor to the right is telling me multiply by 2. You are always going to write this on your paper. If you don't want to write it, you're still going to write it, okay? Always write that times 2, which means in the other direction, I'm timesing by, I said timesing by, that sounded weird, by 1/2. Okay, so what is to the right 4 times 2? It's 8, so go over a space up to 8. What's 8 times 2? 16, so go over a space up to 16. What's 16 times 2? 32. I can't fit that on my graph. Okay, now let's go the other direction. I start at 4 again because it's in the center. And now I'm using the opposite of the change factor, that inverse, which is 1/2. So 4 times 1/2, what's half of 4? 2. Okay, now 2 times 1/2. What's half of 2? 1. Okay, now 1 times 1/2. What's half of 1? 0.5, 0.25, and then you get closer and closer and closer to 0. I hope you're thinking, it's not as bad as the front side. It's not as bad as the front of the paper. Okay, let's get to the next one. 2 and 1/3. Which one's my y-intercept? Which one's my change factor? The y-intercept is going to be in the very front. The change factor is beneath x. Okay, so my y-intercept in the very front is the number 2. And beneath x, my change factor is 1/3. That means I have to start with my first dot at the y-intercept. So put your first dot at positive 2. Don't forget, put your change factor on your paper times 1/3, circle it because it goes to the right. Woof, this is going to be weird decimals because I'm doing 2 times 1/3. So let me type that in. 2 times 1/3, and I get 0.6 repeating. I feel like we did this already. Right about here, a little higher than halfway up to the first dot. And hopefully you can see this. If not, I can try to zoom in a little bit better. These are super blurry. Okay, that wasn't terrible. All right, so then times by 1/3 again, and I get 0.2 repeating. Yeah, we did this one because then it's like 0.07. So 0.2 repeating, 0.07, and closer to 0, never actually reaching 0. So that was to the right side. How do I go to the left? Well, you do the inverse of this. So instead of multiplying by 1/3, on the left, I'm going to multiply by 3/1, which is just 3. Okay, so what is 2 times 3? 2 times 3 is 6. So go over a space up to 6. What's 6 times 3? 18. So go over a space and up to 18 for your next dot. And this graph looks super similar to the one we did on problem number 1. Really, the only difference is the change factor. Notice how this one I had the change factor of 3, and then 1/3 took me to the left. Well, now my change factor is 1/3, and 3 takes me to the left. So what does that do to these two graphs? It flips them around because one of them gets bigger to the right, and the other one gets bigger to the left. Super important distinction to make. If there's a fraction there as your change factor, it's going to shrink in most cases, unless it's an improper fraction, which we will not see on this paper. Let's look at problem number 10. So this one has a fraction as my change factor. Can we make a guess as to which side is going to decrease and which side is going to increase? Yeah, my change factor is 1/2. So if I put my change factor of 1/2 here, I have to put my change factor of 1/2 here. And since this is 1/2, that side's going to get halved the entire time. And that means the other side is going to get doubled the entire time, and it's going to get bigger. So where does this one start? At 4. Let's put our dot at 4. 1, 2, 3, 4. Okay, half of 4, because I'm doing the half side now, is 2. Half of 2 is 1. Half of 1 is 1/2, 1/4, 1/8, 1/16, 1/32. Smaller, smaller, smaller. On the other side, I'm doubling it. So double 4 is 8. Double 8 is 16. And I'm always moving over a spot as I do a doubling. Connect those dots. And this was like the flip-flop graph of this one because, see, we had a change factor of 2 to the right and then change factor of 1/2 to the right. Let's do problems 11 and 12. Why don't you push pause and try to do problems 11 and 12, and let's see how you do. So push pause, and we will look at these. Okay. My y-intercept on number 11 is 5, and my change factor is 1/2. So that means I have to put my change factor over here, and I'm going to be multiplying by 2 in the left direction. That's not the change factor, though. My y-intercept says start at 5. What is half of 5? 2.5. What's half of 2.5? 1.25. And then like 0.75. Wow, I am so good at mental math today. Okay, in the other direction, 5, I'm going to double it, and I go to 10. Double that, and I go to 20. Beautiful graphs. Okay, let's look at number 12. On number 12, this one tricks you a little bit because remember, your change factor is always underneath the x. That is 6. Sometimes people think the change factor has to be the fraction one. Not true. Okay, that means my y-intercept is at 1/2. So I've got to put a change factor of 6 here, a change factor of 1/6 to the left. I don't know why I call it the change factor. You only circle the actual change factor. And yes, you're going to draw that on your paper. Draw your first dot at 1/2. Then times that by 6. What's 1/2 of 6? 3. Okay, what's 3 times 6? 18, is that right? I'm asking you, but I'm alone in a classroom, so it's crazy. Half of 1/6 times 1/2 is going to be a small fraction, and it's just going to get smaller and smaller and smaller and smaller, really close to 0. I'm going to connect these dots, and I'm going to try not to do a garbage job connecting them. Failed. Okay, that one's super steep. What did we have going on there? Well, that was way simpler. Look at how quickly we did that compared to the last one and how much work we had to have on the last one. I want to talk about this last question. What are the domain and range for all of the graphs? So let's go back to the front page. And we actually didn't fill in domain and range yet because I want to talk about them now. Domain and range, we talked about these when we did graphing inequalities, and we used interval notation. So that's telling you domain, how far to the left or right a graph can go. Do you see how this graph has an arrow that goes to the left forever, ever, ever? So that means the domain is going to the left forever to negative infinity. Now this graph is going up and to the right, and it never stops going up and to the right. So that means it goes to the right toward positive infinity. And the range, well, the lowest this graph goes, it never goes negative. I said that like 100 times already. So it can't ever drop below 0. So the range would start at 0, and then it goes up, 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 up forever and ever and ever toward positive infinity in the up direction. Let's look at the next one. This one, the domain. How far to the left can it go? Well, it's got an arrow, so it's going toward negative infinity. And how far to the right? Well, it's always going up to the right, so it can go toward positive infinity, just like last time. And then it never drops below 0, but it can head upward toward infinity. I'm starting to see a pattern. This one, the domain, has an arrow pointing toward the left. That means it can go toward negative infinity. And to the right, that arrow continues on toward positive infinity for the left and right distance. The range never drops below 0 and always goes up forever. That was a really bad infinity that I just drew. Okay, number 4. It still goes to the left toward infinity, negative infinity, and to the right toward positive infinity with that arrow. Then the range never drops below 0, always goes up toward infinity. So all of these follow that same pattern where they never drop below 0 and everywhere else goes toward infinity. So I have negative infinity to infinity, 0 to infinity for the up-down range. Domain goes left-right, so negative infinity to infinity. Range goes up-down, 0 to infinity. So what does that mean about problem number 13? What is the domain and range for all of these graphs? The domain is always negative infinity to infinity. Why? Because the graphs go forever left/right. So what's the range for all of these? Well, the range never drops below 0, always goes up toward infinity. So we say 0, infinity. Something I didn't point out, there's a reason it doesn't have the hard bracket on 0. That's because it never actually touches 0. If you're doing half the distance to something, you never actually reach it. So we would say graphs never reach 0, but go up forever. All right, lots of stuff. I know, long notes. Yeah, good work.